Physics is the science of measurement. Without precise tools to quantify what we see, the physical world remains a collection of observations rather than a set of predictable laws. Every measurement falls into one of two categories. We have fundamental units, independent baselines like length, mass, and time. Then we have derived units, which combine those baselines to measure complex quantities like speed or force. For a long time, the world relied on regional systems. One lab used centimeters, grams, and seconds, the CGS system, while others used the foot-pound-second model. To ensure that an experiment performed in one country could be replicated and verified in another, scientists standardized on the International System of Units, or the SI system. But even with a universal standard, your precision is limited by your tools. Take a standard laboratory ruler. The smallest mark on it is 1 millimeter. That single millimeter is its least count, the absolute minimum value it can accurately resolve. If you need to measure the diameter of a thin wire, a standard ruler fails. When the object you are measuring is smaller than the smallest division on your tool, you can no longer provide a verified number. To advance our understanding, we have to move past naked eye limitations. We need instruments designed to capture the fractions of a millimeter our basic scales cannot see. The vernier caliper is the mechanical solution to the 1 millimeter limit. It allows us to measure with 10 times the precision of a standard ruler. The instrument uses two scales working in tandem, a stationary main scale and a sliding vernier scale on the lower jaw. The least count is the difference between them, 1 main scale division minus 1 vernier scale division. Check for zero error before measuring. Closed jaws should align at 0. If the vernier 0 rests right, it's a positive 0 error. Left is negative. Correct by subtracting this error, like 2.34 centimeters minus a 0.02 error equals exactly 2.32 centimeters. Precision isn't just about using a better tool. It's about the discipline to calculate and remove the tool's inherent mechanical bias. To measure smaller increments, like the thickness of a single wire, we use the micrometer screw gauge. This tool moves us from the second decimal place into the third. This tool operates on a screw mechanism. One 360-degree rotation of the thimble moves the spindle forward a specific distance, called the pitch. The least count is pitch divided by circular scale divisions. Always rotate in a single direction to prevent backlash error. While calipers and gauges measure distance, the simple pendulum allows us to apply this same level of rigor to the measurement of time. Effective length goes from support to the bob's center. One full swing is the time period, equaling 2 pi times the square root of length over gravity. Notice mass is entirely absent. Time period is strictly determined by length and gravity. Science requires us to set aside our assumptions. A heavy bob and a light one will swing at the exact same rate, because the mathematics of the physical world demand it. Let's apply these steps to a common board exam problem. Imagine you are analyzing a pendulum with a recorded time period of exactly 0.5 seconds. You need to find its frequency. Frequency is simply the inverse of the time period. You divide 1 by 0.5, which gives you a result of 2 Hertz. When solving measurement problems, always start by documenting the instrument's least count. Establishing your baseline precision first prevents errors later in the calculation. Next, when correcting for zero error, always place the error value inside brackets with its original positive or negative sign. This ensures you don't lose track of the signs during subtraction. Finally, check your units. Mixing millimeters and centimeters in the same equation will lead to an incorrect result. Convert all values to a single unit before you begin the math. Mastery of physics comes from applying these fundamental rules systematically. Once you account for the tool's limitations and the mathematical constants, the mechanisms of the physical world become clear.